The Milky Way is the galaxy where Earth resides, but if you could look down upon the entire galaxy, you would never spot Earth. Every bright point before your eyes is a star as dazzling as the sun, while Earth is no more than a speck of dust beside them. To the Milky Way, even the largest star is but a tiny dot, barely noticeable, almost dispensable. Yet have you ever wondered, even our galaxy, spanning 100,000 light-years in diameter, is but a floating grain of dust in the universe? Those who have gazed closely at the night sky may have occasionally seen an elliptical patch of light. That is not a nebula. It is the famous Andromeda Galaxy. Just like the Milky Way, the Andromeda Galaxy is a vast system composed of countless stars, black holes, and interstellar matter. Yet it is far larger than our own galaxy. This reveals a profound truth. The Milky Way is not alone in the universe. In the unreachable depths of space, galaxies may be scattered everywhere. This is the Hubble Ultra-Deep Field Image. The area captured in this photograph represents only 1/12.7 millionth of the entire night sky. In other words, this sesame seed-sized patch of space contains approximately 1,000 galaxies. What this means is that most of the tiny points of light you see here are magnificent galaxies like the Milky Way, realms forever hidden from naked eye view. Based on a series of Hubble observations, scientists estimate that our observable universe contains about 1 trillion galaxies. They are evenly distributed across the 93 billion light-year expanse of the observable cosmos, weaving a vast cosmic web of filamentary structures. Most of these are small dwarf galaxies, some containing fewer than 10 billion stars. Our Milky Way is considered relatively large, hosting over 200 billion stars. Andromeda is even more immense, with about 1 trillion stars. Yet, despite knowing the number of galaxies, we cannot precisely determine the total count of stars in the universe, as galaxies vary tremendously in size. If we assume an average of 100 billion stars per galaxy, we can estimate the number of stars in the observable universe to be around 2 times 10 to the 23rd, a number so vast no one can truly comprehend its scale. The sun that warms you each day is just one among that unimaginable multitude. Perhaps only when we truly grasp the immensity of the cosmos do we realize that even the existence or disappearance of Earth or the Milky Way would leave the universe utterly unchanged, let alone the fleeting presence of humanity. In the context of our brief lives, how much do the fame and fortune we strive so hard to obtain truly matter, rather than obsessively comparing ourselves to others? We might instead quiet our minds and embrace the breathtaking richness of the universe and the natural world. What exactly lies at the edge of the cosmos, from Earth to the vast Milky Way, and onward to the fringe of the observable universe? We can actually categorize the cosmos into 6 distinct levels. This video will guide you through understanding the universe at different scales. We know that billions of stars drift through the universe. The sun you bask in every day is one of them. Yet these stars are sparsely distributed. Even Proxima Centauri, the closest star to the sun, lies 4.2 light-years away. The Earth beneath your feet is a planet. Its rotation and revolution create the cycle of day and night and the change of seasons. Planets may also host natural satellites, such as the Moon, Earth's natural satellite in essence. This stellar-centric arrangement, a star orbited by planets, moons, and comets, forms what we call a stellar system. Such systems are scattered throughout the cosmos, marking the first level of the universe. Now, let's zoom out. At scales spanning tens to hundreds of light years, we encounter star clusters and nebulae star clusters are groups of thousands to tens of thousands of stars, like the Pleiades or the Beehive cluster. Nebulae, on the other hand, are magnificent clouds formed from the remnants of stellar explosions. They often stretch across several light years and consist mainly of hydrogen, helium, and plasma. Under the pull of gravity, nebulae coalesce, gradually giving birth to new stars. Thus, we may regard nebulae as both the graves of dead stars and the cradles of newborn ones. This constitutes the second level of the universe. In the 1920s, it was widely believed that the Milky Way was the entire universe, until astronomer Edwin Hubble discovered that Andromeda was, in fact, a galaxy beyond our own. Moreover, billions of other galaxies exist in the cosmos. The third level of the universe is, indeed, the galaxy. On scales of tens of thousands of light years, galaxies are immense celestial systems composed of vast numbers of stars, nebulae, and various interstellar materials. For instance, the Milky Way spans about 100,000 light years and contains at least 200 billion stars. When we expand our view to tens of millions of light years, we encounter galaxy groups and clusters. Among these, galaxy groups are assemblies of dozens of galaxies. The Milky Way resides in the local group, which comprises about 50 galaxies. Galaxy clusters, meanwhile, consist of hundreds to thousands of galaxies. The local group, in turn, lies within the enormous Virgo supercluster, a structure composed of 2,000 galaxies, where every point of light is an immense galaxy. Such superclusters remain countless throughout the universe. The fourth level of the universe is formed by these vast assemblies. If we zoom out further, to scales even larger than superclusters, the appearance of the universe may surpass imagination. At this magnitude, the cosmos is filled with colossal cosmic walls, stretching hundreds of millions of light years. Structures like the Sloan Great Wall and the Hercules Corona Borealis Great Wall. These are woven from galaxies into a cosmic web. Scientists estimate that the universe contains roughly a trillion galaxies in total, interspersed with vast, nearly empty voids, together forming a filamentary cosmic structure. This is the fifth level of the universe. When we journey hundreds of billions of light years outward, we finally reach the sixth level, what astronomers call the observable universe. Limited by the speed of light, this represents the farthest extent, theoretically visible to humanity, a spherical region 93 billion light years in diameter. At such a macroscopic scale, whether human civilization exists or vanishes has no discernible effect on the cosmos. All we can do is cherish the fleeting moments of our own existence. The solar system appears as if meticulously crafted, with each planet possessing its own unique features. For instance, Earth harbors life. Saturn boasts its magnificent rings, and Jupiter hosts the great red spot, the luminous, heat-radiating star you see now, is the celestial body at the center of our solar system, orbiting around it. Our 8 major planets and numerous smaller celestial objects among these planets. Venus is the closest to our Earth. If you ever spot an exceptionally bright star in the night sky, it is most likely Venus. The thick sulfuric acid clouds enveloping Venus create the most intense greenhouse effect in the solar system, causing surface temperatures to exceed for 100 degrees Celsius, making it the hottest planet in our system. No life could possibly survive here. Mercury, the smallest of the 8 planets, is also the closest to the Sun. It experiences extreme temperature variations between day and night, soaring to 427 degrees Celsius at noon, while plunging to minus 172 degrees Celsius at night. Images transmitted by space probes reveal a surface densely covered with impact craters of varying sizes, giving it a moon-like appearance. Then comes the heart of our solar system, the Sun. Its scale might far exceed your imagination, equivalent to 1.3 million Earths combined. Every second, about 600 million tons of hydrogen fuse into helium, sustaining its luminous energy output while transferring a portion of this energy to Earth. In fact, the energy powering your movement and cognitive processes ultimately originates from the Sun beyond Earth. Mars may become humanity's future home. We've already witnessed the successful landings of rovers like Curiosity, Perseverance, and Zhurong on the Martian surface. Mars displays a distinctive reddish-orange hue, bearing resemblance to certain terrestrial landscapes attributed to iron oxide compounds in its soil. Further out lies the asteroid belt, home to approximately 500,000 asteroids, mostly composed of rock or metal. While this number might seem substantial, their combined mass is actually less than that of our moon. Beyond the asteroid belt resides Jupiter, the most massive and voluminous planet in our system, thanks to Jupiter's powerful gravitational influence. It has historically served as Earth's cosmic shield, deflecting numerous potentially hazardous impacts, earning its title as Earth's guardian. Its iconic Great Red Spot, a colossal anticyclonic storm system with a diameter equivalent to Earth's, remains its most distinctive feature. Next comes Saturn. Like Jupiter, is a gas giant, lacking a solid surface, making landing impossible. Yet Saturn's most breathtaking feature is its spectacular ring system, a magnificent assembly of hundreds of millions of ice and snow particles. However, these magnificent rings are projected to completely disappear within the next 100 billion years. The final two planets, Uranus and Neptune, are often regarded as sibling worlds. Both belong to the ice giant category and share striking visual similarities. Uranus uniquely rotates on its side as it orbits the Sun, while Neptune holds the distinction of being the solar system's outermost planet, located for 0.5 billion kilometers from the Sun, where it experiences diamond rain, a phenomenon that captivates many. Beyond Neptune extends the Kuiper Belt. While resembling the asteroid belt in composition, it spans a much larger volume. Some sufficiently massive objects here maintain spherical form under their own gravity, qualifying as dwarf planets, Pluto being the most famous example. Beyond the Kuiper Belt, further outward lies profound darkness. Though this doesn't mark the solar system's final boundary, our entire system remains enveloped by the Oort cloud, countless remnants from the sun's early formation, encapsulating our solar neighborhood across a staggering 2 light-year radius. Only when humanity completely traverses the Oort cloud will we truly depart from the solar system. It's not difficult to imagine that even our entire solar system appears insignificant within the cosmic context. This leads us to ponder what truly gives meaning to our human existence. This is the Milky Way, home to humanity, one of the most common barred spiral galaxies in the universe. If you could observe the Milky Way from above, you would see several enormous spiral arms stretching outward from its central region, forming its characteristic whirlpool-like structure. The larger spiral arms are known as major arms, such as the Sagittarius arm, the Orion arm, and the Perseus arm. Our solar system lies within the Orion arm, about 26.0 light-years from the galactic center on Earth. When night falls, we have the chance to witness the structure of the Milky Way's arms. The milky white band of light spanning the night sky within these spiral arms lie vast numbers of newborn stars, colorful nebulae, and various interstellar dust clouds, all together forming the Milky Way's disk structure, commonly known as the galactic disk. With a diameter of approximately 100,000 light-years. What does this scale mean? Even if you could pilot a spacecraft at the speed of light, traveling from one end of the Milky Way to the other would take at least 100,000 years. Therefore, interstellar travel within our galaxy remains a distant dream for humanity. The spherical central bulge of the disk is called the galactic bulge. When we view the Milky Way from the side, we can see that the bulge rises above the plane of the disk, making it the thickest part of the galaxy, reaching up to 10,000 light-years in height. This is also the most densely populated region of stars, with tens to hundreds of thousands of stars per cubic light-year, including numerous red giants, each with a total luminosity thousands of times that of the sun, making the central bulge appear exceptionally bright. These stars orbit at extremely high speeds around an invisible object, the supermassive black hole at the very center of the Milky Way, Sagittarius asterisk, according to scientific estimates. The entire Milky Way contains between 100 billion and 100 billion stars, all led by the black hole's gravity in their revolution around the galactic center, together forming this immense galaxy. Moreover, the Milky Way is surrounded by a vast spherical halo of light known as the galactic halo, composed of sparse interstellar gas and globular star clusters. These represent the outermost material of the galaxy. Looking further out, we find the large and small Magellanic Clouds, satellite galaxies of the Milky Way, much like the moon is to Earth. In summary, the structure of the Milky Way consists of 3 main components: the galactic bulge, the galactic disk, and the galactic halo. From a broader perspective, the Milky Way serves as a sanctuary for countless stars, nebulae, and celestial bodies of all sizes. But have you ever considered that even our Milky Way is merely a single bright point in the vast cosmos, for galaxies of such immense scale are more numerous in the observable universe than all the grains of sand on Earth. Do you know why astronauts conceal the overview effect from the public? What astonishing scenes do they witness when gazing upon Earth from space in 1987? Space philosopher Frank White first proposed the overview effect, describing the profound psychological impact this unique perspective creates when humans observe Earth from space. The boundless black void of space evokes a sense of terror, as if they exist in isolation from the entire cosmos. In 2016, a U.S. research team conducted extensive surveys among astronauts who had been to space, ultimately revealing startling findings. The overwhelming majority admitted that when looking back at Earth, they experienced unprecedented and overwhelming negative emotions. One anonymous astronaut even confessed he believed humanity would face extinction within 500 to 1,000 years, evoking within him an inexplicable sorrow. China's first female astronaut, Liu Yang, described her extravehicular spacewalk experience. Upon leaving the capsule and entering space, she was struck by the profound darkness, an abyssal blackness so deep that not even bottomless chasm could capture its essence. Confronted with this vista, Liu Yang confessed to suffering immense psychological impact in that moment. She felt afraid to continue gazing into the fathomless void, fearing she might drift away if she loosened her grip. Yet the reasons astronauts choose to conceal the overview effect are multifaceted. Their professional duty requires them to consistently project strength and competence. Any display of vulnerability, fear, or sorrow could be perceived as weakness by the public, potentially jeopardizing future mission opportunities. Through astronauts' eyes, we glimpse perspectives that transcend ordinary human experience. This compels us to reflect on humanity's insignificance in the cosmos and the responsibility we bear as a species toward this planet. When we look outward into the universe, we are simultaneously looking inward at ourselves. The overview effect is not merely an astronaut's experience. It is a shared legacy and revelation for all humanity, as Carl Sagan profoundly observed. About this pale blue dot suspended in the cosmos, every person you ever loved, every person you ever knew, every person you ever heard of, without exception, spent their life here. Contemplating this reality evokes an overwhelming sense of inferiority, a profound impact from the depths of our being, a deep sense of powerlessness and frustration. In a sense, those fortunate few who journey into space witness wonders never meant for human eyes. They personally experience the vast, boundless expanse of the universe, and the spiritual awakening it triggers is something you and I may never fully comprehend. Voyager 1 has miraculously revived. After losing contact due to a sudden malfunction, NASA has re-established communication with the spacecraft. So what exactly happened during this period? On November 14, 2023, Voyager 1 was transmitting data to Earth as it routinely does, but this time the received signal was pure gibberish. Even after attempting to reboot the system, the garbled data remained unreadable, considering many instruments aboard were still fully operational. Scientists refused to give up on it. After a comprehensive half-year investigation, they finally identify the root cause. The Flight Data System (FDS), which is responsible for storing and processing the probe's data, had suffered memory chip damage. About 3% of its memory was corrupted and beyond repair. If it were on Earth, a simple memory replacement would suffice. But Voyager 1 is 24 billion kilometers away. Even a signal traveling at light speed takes nearly a full day to reach it. So NASA engineers had to rewrite the code, breaking up the affected data and redistributing it across multiple sections of memory, effectively working around the damaged 3%. On April 18th, ground crews sent the updated code via the Deep Space Network to Voyager 1. A day later, the probe confirmed receipt. After another day, it transmitted the restructured data back to Earth. Amid tense anticipation, Voyager 1 finally awoke. Scientists were overjoyed. No one had expected that the probe, now traveling through space for 46 years, would speak again. Its original design lifespan was just 2 years. It is powered by a nuclear battery which generates electricity from the decay of the radioactive isotope plutonium-238. But by 2025, Voyager 1's energy is expected to be fully depleted. After that, contact will be lost forever. That makes the interstellar data Voyager 1 gathers in these next 2 years more precious than ever. Have you noticed this pale blue dot? This is the home to 8 billion of us. On February 14th, 1990, scientists had a sudden idea. They directed the Voyager 1 probe, then 6.4 billion kilometers away, to turn its camera toward Earth and capture this awe-inspiring photograph. In this solar system family portrait, Earth is merely an inconspicuous pale blue dot, occupying just 0.1 pixels, a vivid reminder of humanity's insignificance in the vast cosmos. Just 34 minutes after taking this image, Voyager 1 shut down its camera and continued its journey into deep space, traveling at its current speed of 17 kilometers per second. It will take about 300 years to reach the edge of our solar system, the Oort cloud, and another 30,000 years to pass completely through it. Why? Because the sun's gravitational influence truly extends over to light years. Though we may never leave the solar system in our lifetimes, Voyager carries a golden record containing greetings in multiple languages, sounds of nature, and music, evidence of human existence adrift in the universe. Many worrying this might bring disaster upon humanity, given the cold, unforgiving laws of cosmic survival. Yet there's little need for excessive concern. Space is overwhelmingly empty, with immense distances between stars. The chance of an alien civilization finding the record is vanishingly small. As for Voyager 1's ultimate fate, no one can say. With hundreds of millions of exoplanets in the cosmos, why have we found no aliens so far? In truth, there's only one real reason. Earth remains the only known planet hosting life, yet scientists have confirmed that most natural laws governing Earth apply equally throughout the universe. This implies that since all life on Earth depends on sunlight, air, and liquid water, we have strong reason to believe alien life would require the same. Scientists estimate there are 200 billion stars in the Milky Way, with 10 million of their orbiting planets with inhabitable zones, and over 100,000 with conditions suitable for life across the entire observable universe. There are at least 2 trillion galaxies with numbers so vast. The existence of aliens seems almost inevitable, yet to this day, we have not found any trace of extraterrestrial life. Where are they? This is the famous Fermi paradox. The question has sparked endless speculation. Some suggest the universe is simply too vast, taking our Milky Way as an example. The average distance between habitable star systems is about 5,000 light years. Across such distances, even communication at light speed would take millennia for a single exchange, hardly worth the enormous cost and risk of reaching out to a completely unknown world. As we all know, in the bright night sky, nearly every tiny point of light is a star like our sun, many with orbiting planets, some even within habitable zones, potentially super-Earths capable of hosting life, just like our own. Can you imagine what their worlds might be like? Are they futuristic cities with soaring towers and dazzling lights, or hellish landscapes with lightning storms and erupting volcanoes? We may never know. The universe is unimaginably vast. Not only are other galaxies millions of light years away from Earth, even Proxima Centauri, the closest star to our Sun, is a full 4.2 light years away. With our current technology, it would take us 10,000 years to reach even our nearest stellar neighbor. Despite the vastness of the universe, with its countless celestial bodies, it remains regrettable that our exploration of extraterrestrial civilizations is severely limited by distance. One civilization can never determine whether another means good or ill, so the universe resembles a dark forest where each civilization is an armed hunter who must tread carefully while hiding. When encountering another civilization, the only choice is to open fire and eliminate it. Throughout the 13.8 billion year history of the cosmos, perhaps most planets only host simple life forms. Without the capability to explore space, Earth might just happen to be the first planet where intelligent life emerged. Another possibility is that aliens simply have no interest in Earth, just as we don't pay special attention to every movement of ants. There are far more planets than stars in the Milky Way, and some alien civilizations might possess the ability to travel freely across galaxies, giving them countless planets to choose from. Thus, from a cosmic perspective, alien life should be commonplace. They simply exist in spaces light years away, beyond our current capacity to observe. Have you ever wondered what the edge of the universe looks like? Suppose we pilot a superluminal spacecraft that travels 1 light year per second. How long would it take to reach the cosmic boundary? At this speed, departing from Earth in just 1 second, we'd reach the Oort cloud at our solar system's edge, a spherical region 2 light years across, encasing our entire solar system. After 4 seconds, we'd arrive at the closest star system to the Sun, Proxima Centauri, a triple star system, and the fictional home of the Trisolarans. 8 seconds into our journey, you'd see a blue-white shining star, Sirius, a typical blue dwarf, and the brightest star in our night sky. 20 seconds later, we'd reach Gliese 581G, an Earth-like planet just 20.5 light years away. Some scientists believe there's a 99% chance life exists on this world. After 7 minutes, we'd pass the Hyades star cluster, the nearest open cluster to Earth, comprising over 3,000 stars, spanning 13 light years. 10 minutes into the flight, we'd arrive near Betelgeuse, an aging star nearing the end of its life that will soon erupt in a terrifying supernova explosion. After 25 minutes, we'd pass the Orion Nebula, one of the most beautiful nebulae in the cosmos. Venturing inside, you'd find it's giving birth to countless new stars. 2 hours later, 3 colossal pillar-like structures would stand before you, the pillars of creation in the Eagle Nebula, so breathtakingly beautiful they're considered among Hubble's most magnificent images. After 5.5 hours, we'd reach the largest known star, Stephenson 2218, with a volume equivalent to 10 billion suns, capable of holding 1.3 trillion Earths. 7 hours into the journey, as stellar density increases, we'd reach the Milky Way's central region, where the supermassive black hole Sagittarius asterisk resides, guiding nearly all galactic stars in their orbit around it. After 1 day, we'd finally leave the Milky Way. Now, you could clearly see our galaxy's full structure. Astronomers estimate it spans 100,000 light years and contains 100 to 400 billion stars. 1 month later, we'd reach the Andromeda Galaxy, nearest major galaxy 2 hours, hosting 1 trillion sun-like stars, and visible to the naked eye as one of the most distant night sky objects. After 2 months, we'd exit the local group, a small galaxy cluster containing about 50 galaxies, including our Milky Way. 2 years into the journey, we'd discover our local group resides within a larger cluster, the Virgo supercluster, spanning a staggering 110 million light years. After 12 years of travel, we depart the Laniakea supercluster, a massive feather-like structure containing at least 100,000 galaxies across 520 million light years. As we journeyed onwards, we'd witness increasingly vast cosmic webs of galaxies forming immense structures. But our true destination would appear after 1,400 years, the edge of the observable universe, the absolute limit of human observation. Though this doesn't represent the universe's true size, the actual cosmos is 250 times larger. Even at this incredible speed, we could go no further. As the universe expands faster than light, what lies beyond cosmic boundaries, vaster cosmic realms, or countless parallel universes? This may forever remain unknown. In the Milky Way galaxy, our sun resides within the Orion Arm, where it joins hundreds of billions of stars to form this vast and magnificent galaxy. On clear summer nights, we can see a milky white band of light, what people often call the Milky Way, though in reality it represents only a part of our galaxy. Every star in the Milky Way orbits around the galactic center, our sun, along with its 8 planets. Takes about 250 million years to complete one full orbit, a period known as a galactic year. Yet beyond the splendid spiral arms, the most striking feature is the intensely bright galactic center known as the galactic bulge. This luminous spherical region spans 20 light-years in diameter and is 10,000 light-years thick. Why is it so exceptionally bright? Now, join me on a journey toward the heart of the Milky Way to uncover the mystery. As we approach the galactic bulge, we find it filled with ancient stars billions of years old and red giants thousands of times brighter than our sun. The closer we get to the galactic center, the denser the concentration of stars becomes, eventually reaching unimaginable levels. According to astronomers, this region is packed with stars and nebulae, averaging over 290,000 stars per cubic light year. This means if we lived nearby, we could read a book at night without any artificial light. Thus, the extreme brightness of the Milky Way's center stems from these densely packed stars. Of course, astronomers have also discovered a supermassive black hole at the very center of the galaxy, located about 26,000 light-years from Earth. It's known as Sagittarius asterisk, with a mass roughly 4.3 million times that of the Sun. In May 2022, the first image of Sagittarius asterisk was released by the Event Horizon Telescope collaboration. This black hole plays a vital role at the heart of our galaxy. Together with at least 200 billion stars, it forms a barred spiral galaxy, about 100,000 light-years in diameter. The Milky Way as we know it at this very moment. We humans reside in a quiet corner of the galaxy, living on a planet orbiting a yellow dwarf star. Yet all the fame and wealth we pursue in our lives may mean nothing to the universe at large, because we are simply too insignificant. So whenever you feel down, just look up at the magnificent starry sky. It's no exaggeration to say, Earth is but a speck of dust in the cosmos, for the universe is far vaster than we can imagine. What, then, is the true nature of the cosmos? In this video, we'll journey from Earth into the depths of the vast universe to uncover secrets seldom seen. Our first stop is the Moon, the closest celestial body to Earth, and the only extraterrestrial object humans have ever set foot on. The craters on the far side of the Moon record billions of years of cosmic history. Next, we arrive at Mars, the planet most similar to Earth. Though its surface is silent and barren, it's a place Elon Musk dreams of reaching. Soon we cross the asteroid belt, a densely populated region with over 500,000 minor celestial bodies. The largest, Ceres, has a diameter of about 950 kilometers. Then comes Jupiter, the largest planet in the solar system, with a volume 321 times that of Earth. On its surface rages the Great Red Spot, a storm larger than our entire planet. Saturn is often called the most beautiful planet, thanks to its spectacular ring system, made of billions of tiny ice chunks and snowballs, each one a miniature satellite. Finally, we reach Uranus and Neptune, the two ice giants at the solar system's outer edge. Beyond them lies the famous Kuiper Belt. To date, 5 human-made probes have traveled this far. Scientists speculate that our solar system is enveloped by a massive spherical cloud known as the Oort cloud, a massive spherical cloud about 2 light-years in diameter, marking the true boundary of the Sun's influence. Once we leave the solar system, we begin to see countless flickering points of light, each one a star. Together they form the Milky Way galaxy. Beyond our galaxy lies the larger local group containing over 50 galaxies and spanning an astonishing 10 million light-years. Above that is the Virgo supercluster, a colossal structure over 110 million light-years across, containing more than 100 galaxy groups. At an even grander scale, we encounter the Laniakea supercluster, spanning a staggering 520 million light-years and comprising at least 100,000 galaxies. At this level, the universe is no longer a uniform distribution of galaxies, but a vast cosmic web, driven by dark matter and dark energy. Tens of thousands of galaxies form immense cosmic walls, stretching billions of light-years, with superclusters serving as the nodes. Between them lie cosmic voids spanning tens of millions to billions of light-years, extending all the way to the edge of the observable universe. Currently, the observable universe is defined as a spherical region, 93 billion light-years in diameter, centered on Earth. Due to the universe's faster-than-light expansion and the limitation of the speed of light, 300,000 kilometers per second, the portion of the universe we can observe is finite. Light from beyond this cosmic horizon can never reach Earth, so we may never know what lies beyond. What exists outside this boundary remains unknown and may forever remain so. As an ancient saying goes, we are but mayflies in the cosmos, a single grain in the vast sea. We are merely grains of sand in the universe. On the macroscopic scale of the cosmos, even the entirety of human civilization appears utterly insignificant. So why cling so tightly to fame, wealth, and status? Why is Earth's position so perfectly suited for life? Is Earth truly special in the universe as we know? Earth is the only planet confirmed to host life. Its uniqueness stems from its magnetic field and atmosphere, which together form a natural shield, protecting the planet from cosmic rays and solar winds, allowing life to thrive, free from harsh external conditions. Moreover, Earth lies within the solar system's habitable zone, not so close to the sun as to be scorched, nor so far as to be frozen. This allows water to exist in liquid form, playing a vital role in the origin and evolution of life. But what about conditions on other planets in our solar system? This is Venus, closer to the sun than Earth is, and thus exposed to stronger solar radiation. Its slow rotation and thick atmosphere create the most intense greenhouse effect in the solar system, raising surface temperatures to 460 degrees Celsius, too extreme for any known life. This is Jupiter, as beautiful as an old painting, until you dive into its great red spot and witness a storm larger than Earth. Deep in Jupiter's atmosphere, pressure reaches at least 250,000 times Earth's sea level pressure, too extreme for any probe who survive. This is Neptune, where it rains diamonds, a fascinating phenomenon, but as the outermost planet, it lies for 0.5 billion kilometers from the sun. Temperatures on Neptune plunge to minus 118 degrees Celsius, earning it the nickname Blue Hell. None of these extreme environments could support life as we know it. In contrast, Earth orbits at just the right distance, not too hot, not too cold, making it the only world we know teeming with life. But is Earth truly one of a kind? Why is its position so perfectly suited? This question has long intrigued us. If we zoom out to view our place within the Milky Way, the answer becomes clearer. We know that the Milky Way alone contains over 200 billion stars. Among them, about 10 million planets lie within habitable zones with over 100 likely meeting the conditions for life. Based on images from the Hubble Space Telescope, the observable universe contains at least 2 trillion galaxies, each hosting billions to hundreds of billions of stars. Most of these stars, like our Sun, are part of intricate planetary systems. Earth is special in that it orbits within its star's habitable zone, a fortunate position that allowed humans to evolve. But across the Milky Way, planets like Earth may be countless. Perhaps when you gaze at a distant star, someone there is gazing back at us. Although our current technology has not yet detected any extraterrestrial civilizations, we have every reason to believe the universe is filled with vibrant planets, much like Earth.